right, today, let's take a look. Intermediate level stoic. So previously, we've been doing stoichiometry problems that have asked you to go from moles of one substance to moles of another substance. But here we're going to up the ante just a little bit. Okay? What if they don't give you moles? What if they give you grams? Well, you got to do one more step, right? Use molar mass, go from grams to moles. So in today's flip video, solving stoic problems, nothing has really changed except in purple marker here, we're going to use the molar roadmap to go between grams, liters, molecules, etc. Okay? So as always, you want to balance the equation first before you do anything else in stoichiometry. Balance the equation. Looking at those ratios of moles, establish your molar ratios between the reactants and the products. Always get your given amount. Whatever they throw at you in these types of problems, ask yourself how many moles of that substance is that, right? How many moles is that of the substance they give you, right? Using molar mass. And then finally, convert from the desired, from the given unit to the desired unit, right? Using the molar roadmap. All right. So once again, we're going to take a look at a couple of problems here. All right. Look at this one. How many grams of ammonia? Okay, this is ammonia. That's our product. Okay, that's what we make or produce. How many grams of ammonia are produced from 16 moles of H2? N2, nitrogen gas, is in excess. Okay? So really, we have all the nitrogen gas that we could possibly need. It's never going to run out. So when anything is in excess, don't use it. You know this will never run out. You're really concerned about the amount of hydrogen you have and how much ammonia is that going to produce. Okay? So here's our given amount, right? So we start off with 16 moles of H2. And what the question is asking is how many grams of ammonia is that going to produce? Okay? So what's our first step? I cannot go directly from moles of one substance to grams of the other. I can only compare hydrogen gas in ammonia mole to mole. So we have to balance the equation. Right? So let's do that. Let's take our equation and balance it. And there we go. Okay? 3 moles of hydrogen. When 1 mole of N2, nitrogen gas, is present, those two reactants here and here are going to make 2 moles of ammonia, NH3. Okay, so that's our first step. That's a starting point. We have a 3 to 1 to 2 ratio. That's good. That's where you want to be right now. Look at number 2 here in green marker. Establish your molar ratios. I know that N2 is in excess, so I'm not going to focus on that. It's not part of the problem. Okay? I know that there's 3 moles of H2, and that's going to get us 2 moles of ammonia. Okay? And then finally, in red, calculate the moles of the desired unit. So remember, the only way you can make the jump from hydrogen to seeing how much ammonia that's going to make, use your ratio. So let's take our given. This was given in the problem here, 16.00 moles. This was our given information. If I want to go from moles of hydrogen to moles of ammonia, I got that ratio from the balanced chemical equation. Okay? So 16.00 times 2 is 32. Divided by 3, that gets us 10.67 moles of NH3. Okay? So that's going to get us, notice this is still a 2 to 3 ratio, right? 10.67 is a 2 to 16.00, 3 ratio. Okay. But we're not done here. We would be if they asked for moles of ammonia. But they want to know grams. So let's use the molar roadmap. 10.67 moles of ammonia. If I'm trying to go from moles of ammonia to grams of ammonia, I need to know the molar mass of ammonia from the periodic table, which is 17.04, right? How did I get that number? I added up nitrogen's mass plus 3 hydrogen's mass. Okay? 10.67 times 17.04, and that's our final answer. Okay? So in other words, if you started with 16 moles of hydrogen gas, that's going to get you 181.8 grams of ammonia, theoretically. Right? If no one spills anything in lab, the instruments are as precise and accurate as they possibly could be. Does that ever happen? Heck no. Things happen in lab where things get spilled and lost and don't react, but ideally, we call this the theoretical yield in a perfect world. Okay? All right, let's look at the next question here. We'll move on. How many liters of hydrogen gas are needed to react with 45.44 moles of N2? Conditions are at STP, right? Standard temperature and pressure. And we're using the same equation from the previous slides. Let's think about this for a second. STP, standard temperature and pressure. That's 0 degrees Celsius, and that's also 1 atm. Well, what does that mean for us? Here's what it means. That these gases are going to behave in a predictable way. Okay? 1 mole of any gas occupies a volume under STP conditions at 22.4 liters. So that is our conversion factor, right? If our temperature was warmer than 0 degrees Celsius, we would occupy more volume. Think about that. Gases, as you know, expand as it heats up. You ever try to dribble a basketball in the wintertime? Yeah, good luck, right? It doesn't happen because the pressure drops. It occupies less volume. Okay? So let's take a look at this solution. Okay, our last slide for the day. Balance the equation. We've done that previously. Establish your ratios. Okay, we were given moles of N2, and we were asked, excuse me, how many liters of H2 were needed. So I'm comparing N2 to H2. So once again, ammonia doesn't matter. I'm not focused on that in this problem. Right? So we take our given amount here, 45.44 moles. Right? This was given in the problem. And to make the jump between N2 to H2, big surprise. I've got to use my ratios. That's why we balanced, right? So there's 3 moles of H2 requires 1 mole of ammonia to react. So to do the math here, 45.44 times 3 gets us in the ballpark of 136.3 moles of H2. I'm not done yet. We're not done. We've got to get that to liters. So 1 mole of any gas, in this case H2, at STP, occupies 22.4 liters. I multiply that by my moles. In sig figs, we get 3,053 liters. To give you any idea how much that is, 22.4 liters is about a beach ball, about yay big, about this size. And you've got over 3,000 of those, all right, to give you an idea. Okay. Good luck on these problems. I'm going to put up soon some more practice problems on intermediate level and advanced Stoic, and just keep on plugging away. All right, keep on looking at the videos, looking at your class notes, and I'll see you guys and girls in class.